Hey everyone, welcome back to the channel. Imagine a planet where mountain-sized asteroids slam into the surface every single day, turning the ground into rivers of molten lava that never cool down. No oceans, no forests, no cities, just endless destruction. Would life ever stand a chance there? Well, that's exactly what Earth would be like right now, if it wasn't for one unlikely hero, Jupiter. Today we're uncovering the craziest story in astronomy, how Jupiter didn't just form our solar system, it completely rewrote the rules of planet formation across the entire universe. And because of what it did billions of years ago, our solar system became one of the rarest places in the cosmos, and the only place we know life could begin. Stick around till the end, because this one will completely change how you see our home in the galaxy. Let's dive in. First, let's zoom out and look at our solar system the way it actually is, because it's way weirder than most people realize. At the center, the Sun. Then four small rocky planets, Mercury, Venus, Earth, and Mars. A ring of asteroids. Then suddenly, boom, everything gets massive. Jupiter, Saturn, Uranus, and Neptune. And way out in the frozen dark, the Kuiper Belt and the distant Oort cloud. It looks perfectly organized, almost like someone designed it in layers. Small rocks inside, giant gas worlds outside. But here's the mind-blowing part. After discovering thousands of planets around other stars, scientists have found almost zero systems that look anything like ours. Most other star systems are totally different. They're packed with planets that are all roughly the same size, orbiting super close to their star like beads on a string. Some have hot Jupiters, gas giants bigger than Jupiter that are literally skimming the surface of their star, hot enough to melt steel. Others have chains of super-Earths or mini Neptunes crammed together in tight orbits. Our solar system? It doesn't follow any of those patterns. And that's not just strange. It might be the reason we're here. So how do we even know this? We can't take direct photos of distant planets. They're way too faint. Instead, astronomers use clever tricks. Back in the 1990s, scientists watching a dead pulsar star noticed tiny wobbles in its ultra-precise clock-like pulses. Turns out, planets. The first exoplanets ever found. Then came the radial velocity method, measuring how a star wobbles from the gravity of orbiting planets. And finally, NASA's Kepler Space Telescope, which watched for tiny dips in starlight when planets pass in front. Kepler discovered thousands of worlds, and almost none had our small rocks inside, gas giants outside layout. The universe seemed to prefer compact, same-size planet families. So why is ours so different? The answer points straight at Jupiter. About 4.5 billion years ago, our sun was just a baby star surrounded by a swirling disk of gas and dust. Jupiter formed first, and almost immediately started moving. According to the famous Grand Tack hypothesis, Jupiter began drifting inward toward the sun, all the way to where Mars is today. Its enormous gravity acted like a wrecking ball. It destroyed or ejected many of the rocky planets that were trying to form. It scattered material everywhere. It pushed some worlds into the sun and flung others out of the solar system completely. Then, when Saturn formed, their combined gravity created a special tug-of-war. Jupiter slammed on the brakes and started racing back outward to its current orbit. This inward migration, chaos, then outward migration lasted hundreds of thousands of years. When the dust finally settled, only a small amount of material was left in the inner solar system, just enough to build tiny Mercury, Venus, Earth, and Mars. That's why there's such a huge size gap after the asteroid belt. We're literally the survivors of an ancient cosmic demolition derby. But Jupiter didn't stop there. It became Earth's cosmic bodyguard. Without Jupiter's massive gravity, comets and asteroids from the outer solar system would rain down on Earth non-stop. Jupiter acts like a giant vacuum cleaner, capturing many objects, flinging others into deep space, or changing their paths so they miss us. Studies suggest it dramatically reduces the number of giant impacts Earth receives, giving life time to evolve over billions of years. No Jupiter equals no stable climate equals probably no humans. So our solar system isn't just rare. It might be the perfect recipe for life. But here's the catch. We still don't know how rare it actually is. Why? Detection bias. Our best planet hunting tools are great at finding planets close to their stars, but terrible at spotting distant, slow-orbiting giants like Jupiter, which takes 12 years per orbit. We simply haven't watched most stars long enough. That's why new missions like Europe's Gaia satellite are game changers. Gaia is measuring the exact positions of over 1 billion stars with insane precision, looking for the tiny wobbles caused by distant heavy planets. In the next decade or two, we'll finally be able to answer the big question. Is our solar system a common design, or the universe's ultimate cosmic lottery ticket? If we find lots of Earth plus outer Jupiter combos out there, then habitable worlds with long-term protection might be everywhere. But if they turn out to be extremely rare, then our existence really is a 1 in a trillion miracle, made possible by Jupiter's wild early journey. So what do you think? Was our solar system shaped by pure cosmic luck? Or is there something even deeper going on? Drop your thoughts in the comments